I will talk about how to take an existing project, modify it using a link given, and we will use code blocks to implement some operation on our existing circuits. And I will talk about how we would go about to control a motor using a potentiometer with the help of an Arduino. So first of all, I have the link for the existing project in my clipboard. So I copy it and paste it to my browser. And in this page, I'm seeing Tinker this, but instead of this, you will see copy and Tinker because this is created by me. And you will click on that, and then you will have the chance to modify the name of it, and whatever changes you make will not affect my project, the original project. Here we have a circuit consisting of a motor, a DC motor, an Arduino, a potentiometer, and a switch. The potentiometer is where we get the input from the environment, and it is just a variable resistance where we set the value, and that corresponds to some voltage value, which is called analog because it's not 0 or 5 volts, but any value in between those. So we use that input to control our motor, and Arduino should do some calculations to convert from that voltage value we get from A0 pin to the rates that we're going to run the motor at. So this is our interface. Let's take a step back and see how we can use the interface. On the left, you see there's a circuit as we also used for the electrical circuits lab. And on top of that, there's this code tab. When we go to the code tab, there are a few options. You can write just blocks, use like blocks like this to implement the logic, or you can use text, which is some language with special syntax to implement the desired function. In our case, as we want to focus on the problem-solving aspects in this class, we will be using the blocks to implement a function. And as you can see, there are different kinds of blocks that correspond to many functions of our Arduino. So whatever we do here, whatever algorithm we implement here will be programmed into Arduino, and Arduino will be running those. Think about it that way. So any output we choose from here will be the output of Arduino. For example, set pin 0 to high will correspond to this 0 pin, the pin that is labeled as 0, to be 5 volts, because high is 5 volts and low is 0 volts. So there are other output functions that can control a servo motor. That is another kind of motor where you put input degrees and it just goes to that position. You can use speakers that are also outputs. You can use a serial monitor to print words or like print anything or any variables that you're keeping track of. And that is here. Whatever we print will be displayed here. And there's also another function that takes inputs from this serial monitor. We will come back to that later when we implement the circuits. So these are the output functions function blocks. There are input ones, as you can guess, like that reads the pin instead, like we do for A0 here. It can read the degree of a servo motor. It can read serial characters from this serial monitor and like converts or use them in some way. And it can read a temperature sensor or any other sensor like that. There are notation blocks that are just to comment or make notes for yourself or others that are sharing the project. Control blocks are very important. There are blocks that enable you to include like delays in the circuits. The repeat block will be very important as we will be running in a loop indefinitely until the Arduino is plugged off. That is how an Arduino works. It is programs, and when you run it, it runs a function repeatedly forever until it runs out of battery or you plug it off. So the repeat loops will be very important in our case. And as you can see, there are a few ways to implement those. There is repeat 10 times, it just runs 10 times and just quits. And there is the repeat while. So whatever you put in this expression, this hexagon is an expression placeholder. So you can say repeat while this is still true, and it will run this as long as this condition is still satisfied. Similarly, if else statements are also running on these conditions, and when the program comes here, comes to if, and looks at the condition, it decides if it should execute whatever is in the block, or it should just pass that. So if this condition in here is true, it will go in and run those things. So let me show you the if-else block. So if-else block will run this part if this condition is true, and if it is false, it will jump to else and just run that part. Okay, and there's a count function which is also running like a repeat loop. And if you have experience with languages, repeat might look like repeats corresponds to the while loop, and count or repeats this many times corresponds to a for loop, which are basically similar things anyway. And there are math functions. As you can see, this one is hexagon, so we can create a condition with this. But this is like with the round edges, it signifies a value, a constant value. For example, if I take and put this here, it will just be 2. Some constants signifying 2. So it can take a random, it can combine different logical expressions or conditions with and or. It can it can take the absolute value of a number, do other math operations on a number, and these can be used for high or low. As high corresponds to 5 volts and low corresponds to 0 volts, we might want to use this to output some values to motors or to any actuators that we're going to use. So, by the way, actuators are the things we use to give an output to environments, and sensors are the things we use to get an input from the environment. And finally, we will be using variables to just hold values, hold numbers, or any string, any text inputs you might have. So for example, let's think about this case. Let's go and build this controlling a motor example. So we will be reading a value from our potentiometer, right? We need to save that to a variable to be able to use it for the motor. So I will just create a new variable that is called moderate. Now I have new functions that can set or change this value. So let's start. I will just delete these are just example. So let's start with setting, like creating and setting that variable to some initial value. This is not important before we go into the loop. As I said before, we will be running in a loop that goes on forever in our case. And in order to implement forever, I need to put something that is always true into the condition block. So I go and check. So I guess there are many ways to implement this, but I will do this. I put this condition value into the repeat loop, and I say, as long as 1 equals 1, which is always true, I will run whatever in this repeatedly. These could be changed to terminate or not run something in special conditions. But in our case, it will always run. So while we're repeating, the things we need to do is, if we logically think about it, we need to read this, read the value into the moderate, like save the value into the moderate variable we have. Let's start with that. So I go to the input blocks, as we will input from an analog pin. Wait, so I can't just use this, but I need to set the variable again to the input I get from the analog pin. So what this does is, this potentiometer will give a voltage output that is input into a 0 analog pin, and that is something between 0 and 5 volts again. So that will translate into a number when we read from an analog pin on our Arduino. So that value is saved into moderate in each iteration of this repeat loop. Okay. So then what we need to do is, I will just go ahead and try setting the output pin that goes into the motor to that value. So let's see, am I going to use a high, low, or am I going to use the custom thing? I'm going to use the custom one because I want to replace this 0 with the moderate I have. So I just get this. I need to modify it to correspond to the pin that goes into the motor, which is 10. So as you can see, the motor has 2 pins. It says terminal 1 and terminal 2. And the black one goes into the grounds, which needs to be grounded, like any electrical circuit element. And this pin is just controlling the rate of the motor. The higher number we give, the faster it is supposed to run. And in the case of potentiometer, we see 3 terminals. Terminal 1 and 2 are the voltage terminals, and so 1 and 3 are voltage terminals, and 2 is the wiper, which gives the output. Okay, let's go back to our example. So we want to set pin 10 to whatever this motor rate value is. So we are using it directly in this case, but we could just modify, like do some additional calculations on the motor rates in between these two functions, and then input that into this pin. Then I will add something to help me understand the circuit better. As we talked about this before, I will include this to print something onto my serial monitor. And in this case, I want to print the motor rates with that new line. New line means just it goes to the next line after it prints that. And to make it look better, I will also say current rate. This is just the text I print before this motor rate, and I don't want a new line after that. So yeah, after this, so what this circuit will do right now is, we can just start running it. As you can see, it is, in every iteration, it is reading the input from this and printing it here. So as I go and change this, you can see that the value is decreasing. And it goes from 0 to 1023. Okay, let's stop. Okay, so we have most of the function ready right now. One thing I want to add is I want to add a delay for each loop, and I will just set it to half a second. I'm doing this so that the reaction we want to get you want to get from the Arduino is not that much, so it doesn't need to read as soon as it is available to do so. As you could see, like it is reading too much. It doesn't need to be that sensitive. So I'm adding this to ease the Arduino's operation a bit. Okay, so when I do this, it will instead print every half a second, and it is still quite responsive. So let's see. You can see the motor rates printed here, and I can use the potentiometer to vary that value. As you can see, I start from 0, and as I increase the potentiometer, the rate increases. And as I increase it more, the value, about 200, corresponds to 4,000 RPM. And after that, after the value of 255 in particular, it resets. It goes to 0 RPM again and like starts raising. This is because the input we get here, this is a bit more complex than we want to talk about in this course, but what's happening is the potentiometer input to A0 is represented by 10 bits, which corresponds to up to 1,000, as you could see, like 0 to 1,024. But the input the motor is expecting is between 0 to 255. And it basically, the number is basically being truncated to that many bits, and that's why it rolls over and starts from 0 again for the motor. This way you can implement any function that you want with the coding blocks. You can create like additional conditions to take care of additional inputs, outputs, and do the functions you desire. So I didn't implement the switch here, but that is basically a button, like two-state button that is either off or on. Off is 0 volts and on is 5 volts. So you need to implement, like add this function into our algorithm here to implement the second task of our lab.